Hey guys, in this lesson we would go over the application problems of trigonometric functions. Whenever it comes to applications or word problems related to trigonometric functions, the best way is to turn the word problem into graph, then turn the graph into equation, and then solve the problem. So let's read the question and draw the graph of this particular problem. The question says the tides of Cape Capstan, New Brunswick, changed the depth of the water in the harbor. On one day in October, the tides have a high point of approximately 10 meters at 2 p.m. and a low point of approximately 1.2 meters at 8:15 p.m. A particular sailboat has a draft of 2 meters. The captain of the sailboat plans to exit the harbor at 6:30 p.m. Can the captain exit the harbor safely in the sailboat at 6:30 p.m. So this is what we have to figure out. Now, how do we make this problem an easy problem is just turn this word problem into a graph. Now, high point is going to represent the maxima of the graph. So the maxima point is going to be 10 at 2 p.m. So time is going to be represented on the x-axis. Then we have minima point that is represented with the low point of the tide is 1.2 meters, and this occurs at 8:15 p.m. We would use both of these points to make a graph first. Let's say this is the grid. X-axis represents time. Unit for time is going to be hours. Y-axis represents the height in meters. This height will be representing the height of the tide. Let's say the points we have on the y-axis is 2, 4, 6, 8, 10. Because the time is represented on the x-axis in hours, the best way is to start the time at 12, and since the high point is seen at 2 p.m., we would consider the 0 point as 12 noon. Then we have 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m., 6 p.m., 7 p.m., 8 p.m., 9 p.m., 10 p.m., and so on. We don't need any points after that because we need to represent 2 p.m. and 8:15 p.m. on this grid. Now the max point is 10 meters at 2 p.m. So 10 meters at 2 p.m. is going to be here. Min point is 1.2 meters at 8:15 p.m. This is 8:30 p.m. so 8:15 would be here, and if this point is 1.2 would be somewhat here. When we connect the 2 points, this is how the graph is going to look like. So this is the max point and this is going to be the min point. We know because the tides is a periodic phenomenon, so this is going to form a periodic motion. Therefore, it's not going to stop like this. It's going to keep on continuing, and here also it's going to keep on continuing like this, but we don't have to worry about what happens before and after that. Now we've got the graph. We'll turn the graph into equation. We know the first step for the equation is to get the C value, and C is max plus min divided by 2. Max is 10, min is 1.2 divided by 2. That is 11.2 divided by 2, which is equal to 5.6. Second step is to get the A value, that is max minus min divided by 2, and this is equal to 8.8 divided by 2, which is 4.4. Third step is to get the time period and turn the time period into K value. Now we know time period is the x distance or x value between the two max. However, in this particular graph, you're not given 2 max or 2 mins. We are just given 1 max and 1 min. So just taking a reference graph, distance between the 2 max is called time period. However, distance between a min and a max or a max and a min is nothing but half of the time period. So x value between a max and min or min and max is equal to half time period. Now here max value occurs at 2 p.m. Min value occurs at 8:15 p.m. How many hours are passed between 2 p.m. and 8:15 p.m. is 6.25 hours, because 2 to 8 is 6 hours and 15 minutes is 1/4 of the full hour. So we can write it as 6.25 hours. So we know half time period is 6.25 hours. Therefore, full time period will be 6.25 times 2, which is going to be 12.5 hours. Now once we get the time period, k value is going to be equal to 2 pi divided by time period. So it would be 2 pi divided by 12.5, which is equal to 4 pi divided by 25. So this is how we get the k value. Next step is to get the d value, and d is the phase shift. Now let's consider this is the start point of the graph, and we know max is the start point for a cosine a positive function. So if this is the start point, the d value is going to be everything from the y-axis to the start point, and that is 2. So d is 2 when the function is going to be positive a cos x function. Now we would use all of these values d, k, a, and c in order to write down the transformed equation of this particular function, and that would be equal to y is equal to a is 4.4 cos k value is 4 pi by 25 x minus d value is 2 plus c value is 5.6. So this is what this graph is going to be represented in the form of a sinusoidal function equation. Now coming back to the question is asking us to find out if the captain can exit the harbor safely in the sailboat at 6:30 p.m. We know 6:30 p.m. would be somewhat here, and the sailboat has a draft of 2 meters. Draft of 2 meters means the sailboat can only move in water that is at least 2 meters deep. So we need to find out what is going to be the depth of water at 6:30 p.m. If the depth of the water at 6:30 p.m. would be greater than 2, then the sailboat is going to exit the harbor safely. If the depth of the water is going to be less than 2 meters, then the sailboat will be unable to exit the harbor safely. Now, how to use this 6:30 p.m.? Now, what are we going to do is we will be finding the height of the tide, or we will be finding the depth of water at 6:30 p.m. In order to find the depth of water at 6:30 p.m., we need to substitute the x value for time. We know x represents time in this particular scenario, and y represents the height. So 6:30 p.m. is going to be here, which is from the beginning 6.5 hours. Therefore, we would be subbing in x as 6.5, and we will be solving for y, or we will be solving for height. When we simplify this bracket, we would be able to get 18 pi over 25. Next we have to solve for cosine 18 pi over 25 and multiply it by 4.4 and then add it to 5.6. That would give us the y value to be 2.80 meters. Since the height is 2.80 meters, therefore it is greater than 2 meters at 6:30 p.m. Hence we can conclude that the captain can exit the harbor safely at 6:30 p.m. And this is how we solve this type of a problem or any word problem in trigonometric functions. So we always turn the word problem into a graph first, then we turn the graph into equation, then we use the equation to solve for the given problem using substitution.